Next is that is a subset of machine learning and deep learning. So we have various kind of a domain in artificial intelligence. We have that is a various kind of a domain. We can say it's a subset of machine learning and deep learning. Okay, that is to be called as artificial intelligence. So we are going to teach the machine. We are going to give the intelligence to the machine. So how it is learning, how the machine is learning here, and by the methods of that is the machine learning, and another method is deep learning. So we have different aspects of learning here. So we will see the things detailing how it is working, how it is functioning here. So machine learning is a field in computer science that learns from experience without being programmed here. The science behind the ML is to make that is a computer perform actions by themselves. So a machine learning algorithm is a generic program that will understand the data and build models within the data. So in simple, we can say it's a formal definition. So here, with the help of a human intervention, okay, these are the features. By this way, the program is to be done. So, in this way, in this scenario, the machine learning program, everything has been done. So the program has to uh, understand the data, what input has been given. Okay, so which is to be considered as the important features. So everything in many scenarios in the form of supervised scenarios, this machine learning is performed here. Some of the real-time examples, if we take like image recognition, statistical arbitrage, speech recognition, medical diagnosis, extraction, predictive analytics, many different kind of real-world examples over there. So these goes into like different concepts because everything enter into different scenarios in different fields. It is working statistical arbitrage and the medical term is everything is like a ocean. So here I represented with the small keywords. So types of machine learning. In simple words, machine learning means the machine is learning. So with the help of like human intervention. So it is all instruction will be given by like the human. So this is way the programs to be done. So machine will understand the data and process it and give the output. So everything the features should be given properly by the human. So in simple ways, we can say if the teacher is teaching something, the students is asking some questions related to like this machine learning what we have trained, the machine can able to answer. Okay, the teacher can able to answer. Maybe sometimes vice versa, like the teacher is asking questions to the students. Okay, from the teach to syllabus, so the students can able to answer. Sometimes if the teacher is asking some out of syllabus questions, the students cannot be able to answer there. So we can say, so these are the things or like machine learning examples. The supervised learning we can say training the machines using the label data. How the machine has been trained using the label data. So next another thing is unsupervised learning. So uses the unlabeled data to train machines. Okay, like unlabeled data means like it will the machine will learn by itself. Okay, for example, just consider, so I am taking the mobile model, okay, from that is a number system model to now that is a touch model, okay, like a very old Nokia model. Okay, from there to now I'm using touch. I have collected all the phone images and dropped everything in a folder. Okay, the machine is learning everything. Okay, learning everything and just displaying to us. Okay, these are the contents. It is entirely about the phone. That is a different varieties of phone. So outside I have mentioned simply mentioned as a phone. Okay, so whatever images you are giving as the input, the machine will learn each and every, maybe from the maybe 1990s model to till that is the 2020s, what are the models are there, it will learn everything. The machine will learn everything here. So here, so we are not labeling anything. We are just dropping all the images in a particular box. This is to be said to be unsupervised. The machine will learn, take each picture. So in that each pixel is noted and it will assign a weight. By this way it will learn and take decision by its own. So we can say these are unsupervised learning. It just machine is learning by itself. Supervised in the case, at all time we just train the machine using the label data. Just say take the same phone example. In this phone example, if we take I'm just labeling the very old, there is a 1990s Nokia model, is 1991, that is a Nokia's model, and I just representing here. So with it, if by labeling data, this is what the label data, the image, it looks like this. Okay, so maybe like it is not like a plain screen, so it cannot be a long or wide or cannot be things. So something and just representing as a features. So with the bounding box and just labeling, in the case we can say that is also to be called labeled data. So, in machine learning, most probably they will use that is a supervised learning. Even nowadays, like a few shot learning. Few shot learning also the concept is there. When there is a scarce of images, medical images, so they are working with a combination of like a supervised learning and a few shot learning here. So that is also a very good scenarios. There in few shot learning, we can say in that scenario, we are explaining about how to learn to classify. So basically, unsupervised learning or some kind of a classification, there we will do how to classify. Okay, we will give the data. So if I give the test image there, okay, it will classify it and say. So here, uh, even in training images, I will give some set of images. In that is a testing, I will give some unseen images as the input. The machine know to like how to learn to classify. So it will whatever input I'm giving in the testing, even the unseen images, the machine can able to classify them. So that is a scenario of that is a combination of supervised and the few shot learning there. So next is set of like a reinforcement learning, like it follows a trial and error method to arrive at the desired solutions. With a very good example, we can take like if we take some of the gaming scenario. So in this gaming scenario, if we take we can say, so eventually we have some that is a game app in our that is a mobile phone. We started to play, so we doesn't know what are the tactics. Sometimes with very initially first two times or three times, sometimes we may fail it. Okay, we exit out. Okay, so in that scenario, that is to be considered as an error. Okay, you are making some mistakes. So you should know that is a strategy. What is the tactics we have to do to escape? So maybe to move out from here, maybe jump out from the place. So what are the tactics we will learn while doing some mistakes? So we used to say by means of the trial and error method. So these things, the reinforcement learning scenario is working. This is also a very good scenario we can say. So these are all we can say the types of the machine learning. So next is that of deep learning. So in this deep learning, so deep learning is a type of machine learning and artificial intelligence. So the very simple, as I said now, that imitates the way the human gains certain type of a knowledge. So in simple words, we can say self-learning and self-decision making. So it just learn by itself and take decision by itself. That is going to be deep learning. We will be completely dropping all kind of images, all kind of things, and dropping inside the box, and giving to the machine. Okay, just please learn. Okay, started to learn by that is a pixel by pixel. So that is going to be a deep learning. We are not preaching anything there you have to learn in this way. So not doing any kind of scenarios there. So just giving some set of images and giving directly to the machine. The machine will learn the same as pixel by pixel, and each pixel node is given as an input. It is learned. It uses the vast volumes of the data and complex algorithm to train the model. So deep learning is also known as there is a neural organized learning and happens when artificial neural network learns from large volume of data. They are giving the another name which is called that is a neural organized learning. So that is to be, so we have a that is a neural network, artificial neural network. We have that is a only one middle layer. That is the basic artificial neural network. When you enter into the deep neural network, we have that is a multiple middle layer. So when there is more than five or more than three or four, that is to be called as like a deep neural network. So more than three, that is also be called as a deep neural network. So many kind of maybe there are the layers of 20 layers, 50 layers, 100 layers. So if we take some of the model, that is a pre-trained model, if you see there are like a 512 models. So a lot of models are available there. Um, so it's what the major difference of machine learning versus deep learning. This is a very famous that is a scenario here. It is a here it is given as the input here, and next is that of feature extraction, classification, and next is that output. The input is given as here the feature extraction with the help of the human intervention. So these are the features we have to give. These are the features we have to extract. So keep remember of these features. Everything has been said by the human. So they have been programmed here. So then it is classified either like a car or not car. Okay, we can say it is a that is a classification. So maybe like binary classifications where the car is one represented as one and not car is represented as zero here. The same scenario here. I'm just giving this as the input. You just study how you want to study. I'm not going to teach anything. Okay, and simply I can represent say you like this is a car. That's all. But you have to learn. Okay, what are the things you have to keep remember? So everything it is learned by that is deep learning. We can say it's a combination of feature extraction plus classification. So next is the other output. So as I said now, like the deep neural net, we have a multiple hidden layer. The middle layer is also to be called as like a hidden layer. In this, we can say that we have there is a multiple hidden layer here. So I think the features I think we have not seen so far. If you give the output, the black box content, the hidden layer visibility is no chances to visualize. So here there is a sample set of the images, how basically the images taken and what are the features or taken maybe while moving into the layer to layer in the middle layers, how it visualize, how is actually okay. These are all things are represented here. Can visualize you. Next, feature selection. So feature selection, we have gone through these concepts already. So anyway, I will repeat again. Maybe x1, x2, x3, x4. So in this, we have a different set of weights like W1, W2, W3, W4. So it depends upon the feature that is a predominance. The weight is given here. So maybe less weight. It always lies between that is a 0 to 1, maybe 0.0001 to like a 0.999 something. So always like so bias is used for like adjusting maybe to why bias is used to indicate to make the model like a non-linear. If it is going continuously like a linear, the machine does not learn anything. Okay, if it is going a non-linear, so it should not pass by a zero. That is a main scenario here. The summation function, by way of the summation function, the output is evaluated. After evaluating the output, for adjustment, the bias is added here. Each layer bias is there. Okay, maybe like each layer that is each output maybe first 6 pixels or maybe first 9 pixels you are evaluating the case, you will apply a summation. Okay, for that first set of values, first set of 9 values, you will apply a bias after applying the summation. By this way, if it is a that is 100 cross 100, you just imagine for each set you are applying a bias. So then the final thing is activation, whether it should pass by a zero or not. That is to some other thing, non-linear thing. So what are the suitable compatible language if we take? We can say that is a Python and or by easy. How I can learn? Okay, which language are more supported? Python is like even if you're from a different back, maybe not interested even the coding, like you can learn Python is a very good thing. Even R also is very good. We are thinking like it is difficult, but it's kind of elongated code. But we have a lot of database. Some datasets are readily available in our. We can retrieve that dataset very easily into our environment. Both are good. So very initially, to get more attractions on studying this kind of AI, that is you can get into like a Python initially. So we can say Python is a general purpose integrated, very interactive, object-oriented and high-level programming language. So like Perl, Python source code is also available in the GNU General Public License GPL. So in this different set of libraries, so there are TensorFlow, NumPy, Matplotlib, Scikit-learn. These are the different kind of libraries are available to work in different domains or from basic level to research level. These are the libraries which are highly useful to us. So different domain, they will use a different set of libraries. This is not only specific to one particular domain we are using here. So even data science also available here, like pandas for NLP, NLTK, for that is a deep learning NLP and computer vision PyTorch we can use this. And for keras, for designing that is a neural networks, they will be using this keras. For computer vision and image processing, they will use like open computer, that is to be called as open CV, open computer vision. So next are the binding data sets. You can use any kind of, that depends upon the input. Like image in the case, these are the extensions are all supported here. If you wanted text in the case, the textual data is visualized as .csv. MP3, not only this, beyond this, many different kind of MP. This is used in like a speech recognition. We can use this. This is especially they will be using in the data science for processing the data. This for computer vision we will be using the various kind of input details are there. So thank you everyone. So we will see the computer vision in the next video. Thank you and thank you all. Good morning everyone. I'm Gopika from St. Joseph College of Engineering, working as assistant professor. So today I'm going to present that is a top 5 AI technologies we are going to see. So in this, these are the topics which I'm going to cover today. That is the subdomains of AI, starting with the basics with like image processing, biological neuron, artificial neural network, followed by machine learning, deep learning, computer vision, NLP, and finally with the speech recognition. So in this very initially, first we are going to see about like a machine visualization on inputs. So in this, the first, the left side image, if you see in the case, that is we can say that is what is the image what humans see. So the next image is like what computers see. So that is the full of, that is the image, the full of numbers. Okay, how machines see in the case, that is full of numbers. So these numbers always ranges from 0 to 255, not more than like 255. So we used to say each pixel is covered by some number. So these number is to be called as pixel. So from this image, if you see here, like each box is represented, this is to be called as pixel. It's denoted, we can say like x comma y. If you take some particular graph, so like if you plot some particular point, so maybe like 2 comma 3. So the 2 is from x-axis and the 3 is from y-axis. We are pointing a plot. So that plot is to be called as like x comma y. So we are saying that is the coordinates of that particular point is, that is a 2 comma 3 by same as set of. So here we are denoting this pixel because the smallest unit of some particular value. So each value here it is denoted as pixel. So we can say it's a combination of particular color. So the particular color here it is represented as pixels. For example, if you take like this is your, that is a width, this is the height. Okay, that is 10 cross 10. So 10 cross 10 in the case like 100 pixels we will have. So each pixel will have some number. That number is always lies between 0 to 55. So this is how machine is visualizing the inputs. So smallest controllable element of a picture represented on a screen. So you can see this formal definition, smallest controllable element of a picture represented on a screen that is said to be a pixels here. So here, so as I said, like each pixel, the value always lies between 0 to 255. So here, the combination of RGB. So we should not say like casually like that is a color image. So we have to say like that is a RGB image. So RGB image that is lies between 0 to 255. So in this we have three channels: R channel, green channel, next is blue channel. That is a red channel, green channel, and blue channel. So each values lies between 0 to 55. So for how we will get, because we are having three different channels, in finalize how we become a one single number. So in which category it is fixing that the value. Maybe for a very good example, we can take like that is a combination of that is different colors. So maybe we are having different watercolors with us, maybe like red color, green color, and blue color. We have a three different colors. In this three different colors we are mixing some proportion, maybe first is of like 20%, and next is like a 50%, and next is of like a 30%. When you mixing this combination of watercolor, you will that is as outcome you will get some different color by same asset of. So mixing of three proportion in equal way, the output is a different color. The output, the combination, it may be like a dark shades of example, a dark shades of maroon, maybe dark shades of like a blue, or lighter and mild shades of like a purple. So it can be anything. So it has some particular value. It has some code. Okay, it has some value. So that value is represented here as a pixel. So approximately 255, that is 256, 0 to 255, the total value is 256. So 256 into 256 into 256. So how many colors we will have, how it is analyzing, because it have a lot in the color palette, we have a lot and lot of colors. How many? Maybe like 16 million colors we are having here. So by calculating this 256 into 256 into 256, so we will get some that is 16 millions of colors. So from these colors, it just obtaining that number, pixel number, and restoring the pixel number. So depends upon the picture representation. So because different pictures will have a different shades on the screen. So based on that, it will display that pixel value. So this is the way how machine is visualizing. So machine knows only the code, but the human knows only the image. The image, the color image can we can able to see. The human can able to see here. So this is a binary image. In this binary image, if we take in the case like we can see there is a black and white image. So in this black and white image, if you see full of the combinations of zeros and ones. So in the zeros and ones, the zeros is entirely like some pixels. Maybe it is maybe black, okay, or maybe like it may be like here it is represented as white, another is a black. So wherever places the black is occupied, it has some content. So binary, by means two, that is zeros and one. So we can say that the combinations of 0 and 1 is occupied in the picture. So the picture, so wherever the content is present, something is present in the image, that is occupied by the value 1. So other places remain 0. So by this way, here it is represented. Here you can see, so here these places are empty. So these empty places here it is occupied by fully 0, and the remaining things, if the places were occupied by black, it is represented by the value 1. So next is that of grayscale image. So grayscale image, this is also the same as that of that is a RGB image here. So in this RGB image we learn like 0 to 255, the values always lies here. The same as that of here also is corresponds to the value like 0 means black and 255 means that is belongs to white. So that is the usual thing. So how it is representing, how it is displaying to us. So maybe if it make a differences like by using like a darker shades of a gray and lighter shades of the gray. So maybe the values which are very closer to 0, so very close, it represent darker. Okay, the darker shades of gray. Sometimes if the value the very closer to that is a 255, it represent like that is a lighter shades of gray. So these are things we can see here. Okay, this is all about like um, how the RGB image is visualized by the machine. Next binary image, and after that like we have seen about a grayscale image. So everything the value from for that is a RGB image and grayscale image, the value lies between 0 to 55, and that is a black and white image. We know that like the by is a combination of zeros and one. So binary image processing is very easier compared to that is a grayscale and a RGB scale. So before entering into the AI, so how the AI, so in simple, so intelligence is a thing. Basically every human have intelligence to from the knowledge, from the real time knowledge they are attaining. So they are taking decisions in simple way. um, they are learning everything, learning from the environment, learning from the that is some natural causes or everything. So here the intelligence is happened by taking self decision. So in this, if you see here, how the artificial intelligence is introduced is inspired by the biological neuron here. So in this neuron, so these inputs inputs to called be as like That is a synapses here, that is to be called as represented in the biological neuron. So these is considered in artificial neuron as input. So here all the inputs are reached here. Okay, then so this is to be called as soma cell body. All the decision making is done by the soma. Next is to be called as dendrites. So next is myelated axon trend is to be called as myelination. Here only the current passes like voltage, how it is passing the same as that of you want to link to the another neuron. So maybe if I'm asking some questions to you in the case like how your brain will answer, it will connect to the another neurons. Maybe it is learned before, maybe like before 1 month or 2 months, maybe the past year. So it will just jump and connect to the neuron. So at that time, this kind of that is a axon will there is a take decision here, and it is connected to the another neuron. Okay, so like input here, so these outputs has been connected to another neuron. In another neuron we will have this kind of a set of the inputs. So by this way each and every neuron get connected to get the results. Okay, is what the difference of biological neuron versus artificial neuron. So in simply artificial intelligence definitions, what we can say. So it is a mimic of our human brain, how our human brain is working. So that biological neuron is obtained. There it is examined. So next, by inspiring of that, the artificial neuron has been constructed here. We can see the dendrites is considered as an input here, like a number of inputs, n number of inputs is considered here. So the nucleus, that is your soma. So that here it is taken as like a summation, your activation function and biases representative. What does it mean? Like we are collecting all kind of information. Okay, all kind of for a good decision making, whether I have to take a right path, where I have to go. So these are the everything decision making, and also the adjustments, biases for like adjustments. So these are the thing has been taken, and decision is made by this that is a soma here, that's to be called as nucleus. And even like weight adjustments, optimizations, and many things happen here. All kind of fine tuning is has been done inside this artificial neuron. The finally outcome is our, that is we called as axon terminals. Here it is represented as output. So what output? Okay, so this is a comparisons of biological neuron versus artificial neuron. In this, how the artificial neuron looks like. So artificial neural network is a series of algorithms that are trying to mimic the human brain and find the relationship between the sets of the data. In this, if you see here, there is an input layer, middle layer, and output layer. So input layer, so what number of inputs we are giving. So as I said before, you just imagine like that is a width is 2 and height is 2. So width is 2, height is 2. So what is the number of pixels in the case? We can say it is a 4 pixels. 2 cross 2 is 4. So we have 4 pixels. If we decide like a 10 cross 10, 10 cross 10, width is 10, height is 10. So in this case, so we can say like we have that is 100 pixels. So here each pixel is given as an input in the input layer. So we are saying this as a node, like a n1, n2. There is a node 1, node 2, node 3, node 4. So we are representing here as a node. So next layer is a middle layer. So here each node is connected to the another node. Can see here. So the first node is connected to any of the node in the middle layer. So this happens, the priority, the weight is given here. So what weight may be like whether these feature, the node is given as input, the pixel is given as a input here. So whether this pixel is an very predominant pixel, okay, whether we have to give some highest weight or like a normal, it is decided by the machine. So it will just give the weight and is connected to the another node in the middle layer. So the middle layer is not visible to us. We can say it's like more or less like a black box. We cannot able to see anything, but all the nodes in the input layer gets connected to the middle layer. The next final is the output layer. So the simple neural network, how it has been constructed. The input is given in between the middle layer, that is the output layer. This is the basic artificial neural networks looks like. So artificial neural networks is a series of algorithms that are trying to mimic the human brain and find the relationship between the sets of the data. Okay, from one input to another input, what is the relationship between the data, how it is correlated, what weightage is to be given to make that is very important features. So we have to represent this as a important, that is everything. The weight has been assigned by the machines by evaluating the pixels. So these are the various kind of AN. So maybe we will see detailing in later classes. So here basically we will say what is that. If I feed forward neural networks and there's recurrent neural networks and third is a convolution neural network. We have three different kinds of neural networks are available here. So in simple, artificial intelligence. So artificial intelligence is a subset of machine learning and deep learning. So as I said before, like intelligence, so that act as a